So, all right, so the first chapter here, just as it always is, a summary of everything without many details. So web applications are all modern websites. And the fundamental problem at modern websites is they let users submit content. So you can put up a profile, you can put up tweets and Facebook posts and all that jazz, and therefore you get a chance to feed in all kinds of unstructured data that might be malicious, and everybody's logging in, so they have an account, which is important to them, and therefore you can hack into somebody else's account, and now you've got all these security problems, which were not really the case in the old-fashioned web applications like what they called Web 1.0, where you would just put up a page and it would just sit there. There was no login, no password, no script, no buy button, nothing. You just put up like a picture and some text and you could read it. And you can still do that. And if you do that, most security problems are not present. There isn't much you can possibly do. Now, if there's a flaw in the web server where someone can take over the box, which there were in a lot of them, all they can really do is steal data that's on the web server, and you shouldn't be putting anything confidential on your web server. Anyway, and they can deface the site, of course, and take it down, but they can't really do much more than that. However, once you let people log in and put things on there, and then advertise to them that there's actually some control, like Facebook, there's this incredible number of people that put things on Facebook, and then they don't want people to see them. Now, this is just not logical. But Facebook's business model involves convincing their customers that you can put stuff on your wall and only your friends will see it, which keeps on failing over and over and over, but people want to believe this. And so now you have confidential data on a shared server, which is the fundamental problem here. Now you have created a situation where you're obviously at risk. So a modern web app, you've got information, people are logging in, submitting content. They're all seeing different web pages dynamically created based on their cookies and history with different ads. It's taking stuff from all kinds of servers that you don't control, like the advertising networks, and putting in stuff that hasn't been properly filtered. And people are constantly developing new features and rolling them out, and most of those developers don't know anything about writing secure code, which is not really their fault, because there's no college program anywhere you can take that teaches you to write secure code, as far as I can tell, and that's what the Netflix security expert told us when he visited us. He said, that's why I don't want your interns, I don't want your graduates either. We never hire anybody at Netflix that doesn't have 5 years of real experience, because none of you colleges produce anybody worthy of working for us. And that is pretty discouraging, but that is the way it is. They teach you to write crap, and then they expect you to hire a second team called the security team that will clean up your crap, and it's job security for all of us. But it's kind of nuts. And a few companies have gotten fed up with this, like Netflix, and decided they're not going to obey the standard model of having to hire two teams to undo each other's work. But this is not yet popular.
So if you were not recording it, I could have told you some stories.
Oh, well, I can stop it.
I work for a cybersecurity company, and we protect web applications. So.
Yeah. Well, bring it up at the end. I'll stop recording and we can hear. Make a note. I want to hear them. But, and like I say, I don't want to disrupt this class for the sake of the recording. So we will see. All right, so anyway, so as you know, all these people out there, you got online banking, you got auctions, you got gambling, you got your web, your email, and everything else is all out there. Everybody's logging in and putting stuff on here and imagining that the whole world can't see everything they put on there. And all these companies are trying to make that true with varying degrees of success. And then you've got your payroll information, your business stuff, your customers. Then you've got Office apps on cloud servers like Office 365, so all your confidential business documents are up in the cloud. And you know, people, when the cloud was new a few years ago, everyone was real afraid to use it. Now everyone's pretty much got used to using it. I was all for it because I knew how completely incompetent the people at the college were. And I said we'd be better off with Gmail than with us running our own email server, because we had so many problems. I know that we don't know how to secure anything at all, and Google's better. But a lot of people don't have that, and certainly there's regulatory compliance. If you have medical information and you have HIPAA compliance to worry about, for example, then you can't just use average Amazon E2C web machines. You have to pay for a more expensive HIPAA compliant plan from Amazon and configure it more carefully. And Microsoft, one of the big criticisms of Azure, which I've heard is the cheapest way to hit machines, at least it was a couple of years ago, but one thing about Azure is Microsoft explicitly says we have no idea where your data is, we can't even tell you what country your data is in. And that, because they have so much load balancing and copies, and that's okay for some things, but there are certain things where regulatory compliance requires you to know that it's not in there. And one of the big scandals over the last couple of years is the European safe harbor was taken down and then replaced by something else. But it is we are violating European privacy laws constantly by using American services. It totally doesn't meet their standards of privacy, and yet they have to, because there are no European services like Google and Yahoo that provide the same thing for the same cost. So they keep getting limited extensions to let them break European privacy law by using American services. Anyway, so HTTP is connectionless, which is another fundamental issue. You know, HTTP is designed to be fast. So if 1 billion people are all going to Gmail at the same time, the server gets one request and sends one response and forgets everything. And then the next request comes in, it has a response, it doesn't remember that you're the same person that read this message number 8, and now you want to see message number 9. Every single request has to include authentication data. And so the server can totally forget when it's done answering, it no longer remembers anything about you. That's connectionless. And that means every single request has your authentication. So until very recently, about 2-3 years ago, almost everybody put your authentication data in a cookie and they set it in plain text with every request so everybody could just hack into everything. And that's how they got in my Gmail at DEF CON. I was on the wall of sheep. Everybody did this. Google was the first company to move to 100% HTTPS, so everything is encrypted all the time, which is certainly a very good solution, but almost no one else has followed. I mean, a few other companies have, but it is amazing how much of the internet is just security through obscurity. They're doing something totally stupid that is easy to hack into, and there was an innocent period of time when not too many people knew it. Now too many people know it, and they're actually starting to have to secure stuff. So as we know, breaches are essentially common. Every day another big site gets breached. The number of known credit card thefts vastly exceeds the total number of credit cards in America. I mean, they say there's only 2 kinds of people, like people whose credit card has been stolen and people who don't know their credit card has been stolen. So there's a lot of other issues. You can also, once you take over the web service, you can pivot and take over more servers on the machine, and so a lot of other things are owned. And I know it was 12 years ago, I think I heard from Unix system administrators that they said there are strong rumors that the larger organized criminal gangs of organized crime have root on all the main servers, and they're using them discreetly so people don't know. And they have the source code for every major product like Office. And this hasn't been proven, but quite a bit of it has been shown to be true. So there's another thing. People like to publish, this site is secure. They like to put up these sites claiming their site is secure. Like they'll put up things like this, and usually what they say is we're using HTTPS and that makes us secure. And HTTPS does improve some things. Now people are doing something like logging in and putting in credit cards. It's encrypted with a pretty good system, but it doesn't mean you can't have other kinds of logic flaws. The one that got my attention, because I got into blockchains and blockchain voting, was these idiots they want an online voting system, and they claim it is 100% secure because blockchain technology cannot be hacked. And Bitcoin's got hacked, and Ethereum got hacked and totally destroyed it, and the DAO got hacked, and Lisk collapsed within the first 3 hours of launch because people hacked it. And so claiming that blockchains can't be hacked is anyway, if anyone ever tells you something is 100% secure, they are either a crook or an idiot or both. Those are the only options. There is nothing you can buy for any amount of money that's 100% secure. And anybody in physical security or data security that's any kind of professional knows that. If your boss, if you want your website to be up 100% of the time, you might as well just quit, because there is nothing you can do that will stay up 100% of the time. It just doesn't exist. There's always some constellation of disasters that will overcome your security. You can talk about 99, you can talk about 99.999 and things like that, but 100 is a number that doesn't exist in this imperfect world. Anyway, and here's an example. Your textbook authors a few years ago found this. Here's how many sites have broken authentication systems, which means that you can steal passwords or cookies or somehow trick it into thinking you're somebody else. And there's access controls so that even when you have not stolen a token and you're logging in as an unprivileged user, you can run functions that belong to someone else. This is very common in home routers. SQL injection is the huge one. You'll be doing it in the projects. It is, by the way, the #1 most important flaw in the world, by far. More than 95% of all stolen data in the world was stolen through SQL injection. It is devastating. It is easy to exploit, and you're getting absolutely nowhere. SQL injection was invented 15 years ago by Rainforest Puppy, and at that time 11% of the web was vulnerable, so we've had classes like this and OWASP and a huge campaign of educating the world, and now we've gotten that number down to 11%. We're getting absolutely nowhere, and if you take a SQL programming class here or anywhere else, they will teach you to write crap that's still vulnerable. It is disturbing, but that's the way it is. Every time you patch one, someone else graduates from college and puts up another one that's vulnerable. So Cross-site scripting is huge. Almost every website has this problem. It is hard to avoid, and no one really cares because it's not very dangerous to the host. Cross-site scripting does not allow you to take data off the server. It just allows you to mess with other users. And that is arguably not the server's problem. This is probably could be regarded as a legal issue. If I put up something like MySpace had a cross-site scripting flaw, so some guy called Mikey, I think, made himself the most popular guy in the world in like 3 hours by writing a worm that would make you put him on your friends list and infect all your friends. And so in like 3 hours, he had like 100 million friends on MySpace. And the question is, if you make an insecure site and people put up scripts and infect other people, are you responsible for that? You know, if we make the college fantastically insecure and let some rotten people come into class and shoot the other students or something, then you could maybe sue the college for that we should have created a more safe environment. But I think the precedents aren't there. So right now, apparently, you can put up cross-site scripting vulnerable apps and your users can attack each other, and it really isn't your responsibility to do anything about it right now. Anyway, information leakage is huge, and cross-site request forgery is the one I described, where you steal somebody's cookie and get in their account. That's one version of it. Another version is clickjacking, where you put up a website and it has a link, and the link goes and tries to buy a book on Amazon. And if you happen to have another tab open in your browser logged into Amazon, it will work, because the request made in one environment runs in another. And that's cross-site request forgery is one of the examples of it. There's a lot of these out there. Here on mobile devices, mobile apps are enormously risky. Not only because the operating systems are designed primarily to be small and use very little power, but also because they have very small screens and they no longer bother to show the users diagnostic information that would help them on the desktop. So most people, for example, are completely unaware that their mobile device is sending unencrypted credentials over the web or using broken HTTPS. And here's the mobile top 10 risk. And these are ubiquitous. And I remember when I taught the mobile app class a couple of years ago, I went through this. And out of the top 10 banks and stockbrokers and insurance companies, 8 or 9 out of each of those groups of top 10 were vulnerable with code modification, and quite a few other vulnerabilities too. The green ones here are the only ones that actually fixed it when notified. The others still haven't fixed it and don't care. And then there's a lot of colleges with problems. I did this before I found out it wasn't legal. I found the problems at colleges and notified them. And there were a ton of them. And there's one here where I'll probably talk about later if it seems worth it. May put it out next time, where I talk about cleaning up a site. I showed some people at the end of last semester. I finally got to clean one of these sites that had been infected by these redirectors that redirect searches that come from Google to steal their ranking. I got to see how it works on the inside. And that's good, clean fun. And we'll certainly play with that more later. So the core problem here, the way you hack into all these sites is by sending malicious input in. Instead of typing in a normal username and password, you put in punctuation marks or 10,000 characters or various bad things. And the problem is people just don't think about this, and you pretty much have to think about it all the time. And I must say I sympathize with developers. You know, if you're like a poet or an artist, you can't be constantly second-guessing everything you think. Saying, oh, I better not, that's a bad idea. But you kind of have to be that way with security. So maybe there's logic in the current team where you have one creative team writing stuff and then the security team being the friction. No, don't do that, take this away, take that away. Maybe it's better to have 2 people bickering than one person trying to somehow do the active and the inhibition together. Yeah?
A lot of languages have authentication libraries where you, as a developer, don't have to write your own.
Yes, and that is certainly a big step, is to just have some kind of automated tool that avoids the big problems. But for, as we'll see, to really be secure, you have to think at every step. So in a way, it kind of makes sense to design it and then have a security team go through and add security controls here and here and here and here and here and here. Anyway, that's how we're doing it. So one thing people frequently overlook is they think they can put client-side controls like JavaScript in the browser and have hidden fields where you can't type anything in the field and think that means users can't mess with it, but all you have to do is run a proxy and you can change the data after it leaves the browser but before it gets to the server. And the textbook that we're using was written by the author of Burp. Burp is the #1 tool here. It is the one people use to win bug bounties right and left. It makes it very, very easy to capture what's coming out of the browser, analyze it, modify it, and send modified versions up to the server, which is what you have to do to find these problems and exploit them. So we spend most of this class will be doing projects in Burp. So you can change the price of an item. If the price is determined by the client and not the server, you can change a session token to get in someone else's account. This is what Weave did. He found that AT&T IMEI number was just plainly visible, so he made a script that would try all 100 million possible IMEI numbers and find out the email addresses for all of them. And then he conspired over unencrypted IRC chat to harm AT&T with this information and then dumped it. And he probably would have gone to prison, except he had a smart lawyer that got him off on a technicality. Anyway, you can do SQL injection, and SSL will not stop any of these things. SSL just means it's encrypted, so nobody but you can modify it. But still, it gets to the server, and if there's a problem in how they handle the data at the server, SSL is not going to save you. So these sites saying we're secure because we use SSL are deceiving people. They have blocked one problem by using SSL, and that's a good thing, but they haven't blocked everything. So, in general, too many people don't understand security. They don't understand the different kinds of risks, so they think they blocked everything when they block one hole. There are too many people too many developers throwing things out there fast instead of having a team that makes one product that a million people all use. Everybody makes custom development, and therefore it's the expertise of their little team of developers they're counting on to make things secure, and that's of course more likely to be wrong, especially with the Internet of Things, where now every object in your life is connected to the internet, and some little team of God knows who wrote that code, and an enormous number of them are just trying to make it fast and small and cheap, and nobody really understands or cares about security, and so you have nonsense like the talking Barbie, where your child is talking to Barbie, and it's sending all your child's voice up to the cloud server to turn it into, to understand it, to make Barbie's answer, and recording it all and putting it on an unsafe cloud server where everyone's stealing it. And this kind of stuff is just all around. Yeah.
Pacemakers are vulnerable to this.
Oh yes, all the medical devices have been totally vulnerable until that's what Joshua Corman's I Am the Cavalry project is. The whole medical industry, they make all the devices they implant in people, never thought of security at all. And again, I don't blame them. They thought about how to make it non-toxic, how to make it last a long time so they don't have to do surgery to put in the battery. They got issues that mattered to them, and the idea that a malicious attacker would send data in and mess with the pacemaker was just not on their radar until very recently. So there are a ton of people with unsafe implanted devices. Anyway, so the issue, there was once a time, until 2002, this was Microsoft's official recommendation, you should have a computing center, you have computers set up on a desk, and then you should have a boundary of security, and then you should have a firewall protecting you from the internet, and that's all you need. This is the old idea where you can somehow define the good guys are in here and the bad guys are out there. We just need a guard at the gate here and everything will be fine. This is madness now because people are bringing in smartphones and USB drives and connecting to Dropbox and VPNs, and there is no sense in which your trusted perimeter is not full of a million inputs. And so it's far more complicated. But now you do have your web app running on your server, which you control, and all the people are sending in data from the browser, which you don't control. So there is certainly one big boundary there between the stuff that came from the user and the stuff that came from our own apps. But your app is not really under your control now because you have widgets and ads and stuff coming from other people. So it's not as simple as one boundary to secure. You have to consider every component and secure its inputs and outputs at each step.
There are CDNs too.
That's right. There's CDNs between you and the servers. There's just one thing I thought about is if I play like a YouTube video, there used to be something called a client and a server, and that went away around 1995. If I play a YouTube video, who's doing that? Well, Google's doing some of it. My ISP is doing some of it. My CDN is doing some of it. My routers and switches are doing some of it. My processor's doing some of it. Some of my browser. There are a giant group of computers are each contributing in ways to make that video play. It's not like there's a client that just is the passive recipient of data and a server that just does all the work. Not at all. So anyway, that's the new security perimeter. You can attack users with cross-site scripting and drive-by downloads. You can compromise an email account and get into other people's things. So you can measure if vulnerabilities are decreasing or not. Now I thought this was pretty interesting. I went through the top 3 content systems, which is, I think I put this here, CMS systems. There are 3 of them that matter. The king of everything is WordPress. Something like I think 20% of the web is WordPress or 15% or something. And when I first looked at it, I said, this is horrible. I mean, remote code execution is 53 vulnerabilities in WordPress, and SQL injection is 34. And each of those are the end of the world. That means you own the whole server. You can do anything at all. But then I looked at the numbers over time. And you see the vulnerabilities peaked, especially the code execution vulns and the SQL injection, which is really important. They peaked in 2008 when the whole web was a god-awful mess and everybody's getting hacked. And then people started shaping up. And as you can see, they really went down. They don't continue to find so many more of them. And that's also true of Joomla. The same story. In 2008, it was god-awful, 80 code execution vulns, but now it's down to only one or a few in the last year. And the same for Drupal. These are the top 3 content management systems used by people, and they all peaked around 2008 when people first began to learn this stuff and see how bad it was, and they all got a lot better after that as the content management systems actually had to grow up and say, we have vulnerabilities, we're going to have some way to report vulnerabilities, some way to patch them, and a system here whereby we will eventually get rid of most of them, and our developers will get a little smarter and not keep writing as many new ones into it. So things are getting better, but it's still pretty bad. All right, and the one thing that's not decreasing is the more subtle errors, like logic flaws, where you just haven't thought this through. There was a famous one about 4 years ago, where you could get into someone's Gmail account, you would go to Amazon, and you would call their help desk, and they would tell you like the last 4 of their social security number, and then you would call eBay, and they would tell you something else, and that would be enough to get in here. And this is the kind of stuff that is not a bad line of code. It's a logic flaw that's hard to fix. So anyway, that's the first chapter. And so the core defense elements here. You can limit what users can do. Authenticate them somehow and then don't let them do too many dangerous things. You can read all their input and take away the dangerous data from their input. You can do things to frustrate attackers. And you can do things to help administrators monitor and configure the server. Those are the general things you can do to protect a server. So for user accounts, you have to let them log in somehow with authentication. You have to somehow keep track of who is logged in and maintain that login state and somehow know when they've logged out. And you have to somehow limit who's allowed to do what once they're logged in, once you know who they are. Username and password is the weakest and most common method because it's cheapest. And it really should only be used for people that don't care very much about security. What's better is to have multi-stage, like 2-step login. Even where you have something like an Android app giving you a second factor and 2-factor authentication. What's even better is to have something that can't be stolen so easily, like a certificate or a smart card, where it's actually a long cryptographic thing that a human doesn't have to type in, so it can really be a 2048-bit public key off your smart card. But there are weaknesses. There are other things you have to have. As soon as you have a login, you're going to have to, what are you going to do when people forget their password, lose their smart card? You're going to have some kind of alternative system, and that is almost always a wide open door that anybody can sail in. That's how they got in Sarah Palin's Gmail account and everybody else, because this is real expensive. You have to pay for humans to sit on the phone, or you have to make your customers drive into the central office and show up and compare their photograph with a photograph on file or something. And that might be fine if you're like a military base, but if you're Yahoo, you have all these people with free accounts and you can't possibly pay someone to take care of them, so you have to have some kind of simple way to handle a lost password, and that means anybody can pretty much get in.
I can tell you that a certain bank said that the account recovery costs them $40 a phone call. So
That sounds very reasonable to me. Yes, I mean, that's why the fundamental thing, so many people say I had a Google account and Google took it down and no one will talk to me. And that's the point, it was a free service. This is a fundamental issue I should mention. Never base your business on a free service. If it matters to you, you should be paying for it. If you are not paying for it, you are not the customer, you are the product being sold to someone else. So this is why people do things like put up a YouTube channel and make videos about sewing or cats or something, and then people look at the ads and they make their living off this, and suddenly Google cancels their account. And there's no one that cares, you can't call anybody, there's no process to beg, their data is just gone. They couldn't care less, it was a free service. They say, well, make a new account. Get lost. What do we care? They say, but my whole life is based on this. I says, well, that is your problem because we have no service agreement with you. You didn't pay us money and get some level of guaranteed service. You should have used Vimeo, where you pay $60 a year, and now you have the right to demand some service. But if someone's giving you something for free, you are obviously of no value to them, and they have no obligation to treat you fairly, and in fact, they have an enormous business need to never talk to you at all. And just put you in some automatic system. So you better have your own copy of that data and your own plan for when they decide they don't like you anymore. They won't even tell you why they kicked you off. Just poof, we're tired of you, go to hell. So here's login function. So you can have Good things to have are only so many attempts before you get locked out, and then rules like characters and letters and numbers on these things. These are generally good policies to have for a login function. But here's common problems. Predictable usernames are true almost everywhere. Passwords that can be guessed are very, very common. I know if you follow the security people on Twitter, it's entertaining. I think it's Delta or American Airlines has a system where you can't have a password longer than 8 characters, and you can't have any special characters in it or anything. Everyone's screaming at them like, God damn, why would you make the password shorter? What are you, idiots? Yeah.
And City College has people log in with their birthday to the
It
Wi-Fi.
totally does.
I mean, that is a.
Oh, not only the Wi-Fi, but the thing, Web 4.
Yeah.
That gets your grades and stuff. I bet that's not even legal. I mean, we'll see. This is, by the way, obvious attack. I mean, one of the students was even going to write this up. I think they decided it wasn't. Or they decided last year we do security audits at college, and one of the students wanted to make something with hack into people's Web 4, but they decided it was out of scope. But he said, all you have to do is look at how old people are and guess their birthday. And you can guess, I bet if you figure out the average age of people is like 19 and go 19 years ago, you'll probably count like 10% of the students will be there. And how many guesses do you get before it locks you out? And there's a lot of students.
Or just find their Facebook, their birthday would be right there.
That's right. So, I mean, anyway, so that's the thing. Passwords that can be guessed and other kinds of defects in logic are very common. Session management is a huge issue. You have to somehow know who somebody is after they log in. You can't keep making them log in over and over. You have to remember who they are and how they do things. So you have to have some kind of token that proves they are somebody, and that's typically a cookie, and that's often handled very badly or generated in a non-random way so it can be predicted or guessed. One thing that will get you big bug bounty payoffs, I've seen quite a few like this, I think Amazon paid a few like this, and Yahoo and even Google, is you go on their site, you click on like recover my password or something, and they send you these long tokens, and they found out that some of those tokens are the same token that's used to authenticate. So they use the same random number twice. So you find, that was it, I think it was Pinterest or something, you could go to view somebody's picture, and when it said no, you can't view the picture, it would send you this long token, and that was the same token for password reset or something, so you get in people's accounts. This kind of stuff happens a lot. And the only way you find it is by using burp and vigorously collecting all the data and scrambling around and trying various combinations until something interesting happens. So your tokens might be predictable or poorly handled so people can steal them. And your access control is tough. You have a group of users, you have roles of users like administrators and customers and stuff, and very often the process of deciding whether to allow people to get at things is flawed. One common one, there was a really hilarious one with a router, D-Link routers. I made a video a few years ago where all you had to do was log in with a user agent that was backdoor backwards. And this would not only elevate you to administrator, but it would change everyone who connected to the router forever to be administrator now. It would like cancel the authentication on the router. It was bloody awesome. This is the kind of stuff that was somebody's test feature that they forgot to take out of the production run is what it looks like. Anyway, that's of course another problem, and this is why this happens. If you're a developer, you make your security system, it doesn't work, you're locked out. I destroyed one of my servers this way. I was tired of using passwords. I switched to certificate authentication. I screwed it up somehow. I was locked out. Shit. It's all gone. It's a cloud server. I'm glad I backed up that data. I spent the next day rebuilding my server. Boy, I even had a recovery plan. I had a telnet session open, but I was on a wireless network and it dropped my telnet session. I said, man. And that's why I remembered Kyle Rankin, who's the Unix expert. He talked about how to do this. He said, you always have 2 alternatives running before you do anything to authentication. Or you'll be sorry, and he wasn't kidding. Anyway, all right, then you got user input. Typically at the input validation, 4 characters, a valid email address, only numbers and all that jazz. This is good, but it's usually enforced on the client by JavaScript, and that doesn't really do anything at all. You got to enforce it also on the server. Then the problem is some text comes in, like a social security number is just numbers and dashes, but a lot of people want to write like blog posts, and they want to put formatting tags and URLs and pictures and videos and all sorts of stuff in there, so it's not so simple to just filter out certain characters and say it's acceptable. And your cookies are coming in, you got hidden form fields, a lot of people like to use those, and all kinds of parameters going in, and the user agent and such. There's normally automatically generated by the browser. There's a ton of exploits that involve messing with the HTTP header fields that a normal user never knows about. But people forget about them, and there's buffer overflows and exploitation in there. So the general ways to prevent this, the weakest and most common solution is to reject known bad inputs. Filter out things that you know are bad. So try to take out, apostrophes and less than signs and greater than signs and percent signs and stuff. The problem is you have to list all the bad things and take out all the bad things, and that's a losing game like antivirus, because all the bad guys have to do is come up with a new bad thing and they get in, and there's an endless list of new bad things. So here's one. If people block select, you can get in this way. This will go through a lot of web application firewalls. I found that a very simple thing like this will defeat the antivirus at GoDaddy. If this is blocked, try that. This totally works. SQL injection. Most web application firewall SQL injection, just take a list off Wikipedia, like the 100 most common SQL injections, and block them. So if you change them in a trivial way, it's not matching, sails right through. There's another one. Here's a select SQL command. And since it's going to block it, you just put comments in the middle, which won't matter, but they'll break up the pattern so it doesn't get recognized. Here's a script tag that you're trying to put in, or a cross-site scripting filter. If you put a null byte before it, then it will terminate the string that's being compared to something, so it won't detect it. But browsers don't mind a null byte. C does. The browsers will just take the %00, let it go through. You can put a null byte in the URL, and it doesn't stop the function of a browser. It just stops the function of C variables. And that's, of course, the fundamental issue of all these, is you have something in one environment being interpreted in another environment. And therefore, you can slip something through that's okay here, but it's not okay in the next step. So what's better is whitelisting, where you know what you're supposed to be getting, and you only accept things that are good in context. Like this is supposed to be a blog post, so all I want to see is formatting tags and nothing else or something. But anyway, the problem is there's a lot of unstructured data that doesn't really follow simple rules. You're blocking SQL injection by blocking apostrophes, which is not all that strong anyway. What are you going to do with input that really has apostrophes, like human names that really have apostrophes in them? And so sanitization is the more general version of this, where you somehow render dangerous input harmless. You can do HTML encoding, where space becomes %20 and apostrophe becomes % something else, and so on. And this, again, is tough if you have multiple kinds of data. So boundary validation is what they recommend. And this is where I observed, this is essentially, if I was running a business, I would hate to hear this message, because I do not know how you can take a bunch of productive programmers that are working all day doing good work and reasonably expect them to do this. But this is what he wants you to do. Let me go down to the picture here. Okay, so you've got a website. In come people logging in, then they have a SQL injection to see if they got in the right password, then they send a SOAP message down to a SOAP server to get the rest of their profile information, and now you show them the profile. And you have to have each of these processes sanitized in context for what's coming into it. Every one of these servers and every one of these processes has to assume that everything coming in is malicious and clean it, and assume that whatever's going out could be an attack on someone else and clean it on the way out. And so each of your developers that write something like a SOAP service now has to figure out what all the risks are to a SOAP service and block all the bad data coming in and the bad data going out. And that's a lot more work. You know, that's the way it is. They call that boundary validation. Yeah?
I got a brief question about that, because this kind of happened to me. Like, let's say, just an example, Google Apps, and so
Yeah.
you're trying to get something that they don't want, but
Yeah.
Bill actually adds the tags. Like, I've gotten error messages like that, where you're
Yep.
like, what's
That's
the
right.
error? Like when I'm trying to do an ADB bootload, do you know what I mean? I'm
Yeah,
like,
this is a huge issue. Whatever you do to sanitize the data might break it for the next step.
That's what it, yeah. That's
That tends to
exactly-
happen. That's the problem. So I mean,
yeah.
how is your person who's writing like one stage of this supposed to really understand what assumptions the next developer is making with the data coming in?
Right.
And so you're going to create all kinds of problems putting in these security solutions, and that's what makes them expensive. So I mean, it's not a pretty
Yeah,
game.
you get the validation, like, oh, validation on that. You're like, what are you talking about?
Yeah. So here's an example here. So that's sanitization is one option, which is another option is safe data handling. Write code that won't do a bad thing even if malicious data comes in. This would be nice if you can get people to do it. Like SQL could be using parameterized queries. And then it would not matter what characters come in, you're no longer going to have SQL injection. But that's nice when you can do it. Semantic checks are where you take your knowledge about what's going on in your little module and you use it to look for things. So instead of just filtering out letters and numbers, take only valid account numbers. And you have some list of valid account numbers and make sure it's really on the list of valid account numbers, that sort of thing.
What about app roles? like with database stuff, do they still even
App
kind of
roles?
do that? Yeah, where you like,
I don't think I know.
you assign the program like a certain, like almost like a user account, like a bit of rights, but that's all they have? Or?
I don't know. It sounds like a pretty good idea. I know there is a thing called App Armor in Ubuntu that I hit a few times until I learned about it. It's like, and it has limited access to the file system for each application.
Right.
And so you have to like, it's sort of like an internal firewall,
Yeah,
limiting
the
access to the
application
file
has
system.
its own permissions. And
Yeah.
That's all it can do. It doesn't
That
matter what you type.
that fouled up some things I did until I learned how to turn it off. But it's that's part of us SE Linux that was developed for the military, Security Enhanced Linux, where you have, and it means just more and more headaches for people. You write code and it doesn't work because there's yet another security issue limiting what you can do. This is the fundamental problem. The more secure you make it, the more you can't do your job. Anyway, the old system was anything coming from the user is bad and untrusted. Everything on the server side is good and trusted. And that was fine back in the day when there was one client and one server. But the problem is now your server is a complex mess of app going to app, going to app, going to app. And there's no, you can't say where the client and server is. Everybody is a client to the things after them and a server to the thing before them. And so it's not so simple. So instead of having a trust boundary, you got all kinds of trust boundaries. Every single app has data coming in that it can't trust, then it has to sanitize it, and then it has data going out that might be hurting somebody else. So each component treats its input as potentially malicious, and they validate it at each step coming in and out. This is the way to make something secure, but and I guess this is what Microsoft did, because I mean, Microsoft XP became so popular for like 14 years because Vista was held up for like 6 years by making it secure. Microsoft stopped all development on Vista. They gave it away free as XP Service Pack 2. They made their entire security team stop and study this book called Writing Secure Code and rewrite the whole of XP with this kind of thinking and create XP Service Pack 2. And then they said, if you're using anything before XP Service Pack 2, we cast you out. We will never speak to you again. God have mercy on you, because when we wrote stuff like Windows 98 and Windows 2000, our programming team had never even heard of a buffer overflow. We did not even know that we were supposed to be avoiding this stuff, and we will never find all the problems and fix them. God have mercy on you. XP Service Pack 2 is the first version where we actually knew anything about security, and it really was a lot better. And every further version gets more and more better. But this is a problem for a company like Adobe, making these horrible products, PDF, and they make Flash. And, yeah, these horrible things responsible for like hacking everything, and you have to suddenly, your company has to say, okay, we're not going to make any profit for the next 2 years. We're going to rewrite all our existing code so it does exactly the same thing. How's that? This is hard to tell the boss, but that's what you have to do. It's like when you accept, oh my God, I have a problem. I have to abandon everything and go to rehab. You know, my whole life is shot, and I can't just pretend it's okay. Just slap a Band-Aid on it and keep going anymore. But that's a hard lesson, you know. Anyway, so that's the game here. So, by the way, if you don't know what SOAP is a more modern way of moving data around. And the point of SOAP, there are all these techniques. You send an HTTP request, and you put these XML tags in to move things up. There are a whole bunch of these out there, ways to send structured data to a server. And it's real important, especially in the mobile stage, when you log into your mobile app and you want to see your profile or something, it has to somehow send some data to the server request and get some data back, and there are about 8 common techniques to do this, and each of them have their own flaws and their own ways. Well, however you structure the data, there is some way for the data to have the unexpected tag, and in this case, it's XML injection. So here's something I put in, you can tell because it's spelled wrong, Microsoft. So I could have put less than and greater than signs in this, and injected XML into this, which would cause this to be misinterpreted. And that leads to a lot of fun things. One of the funner ones is SAML, Security Assertion Markup Language used by mobile apps, where it has security assertions like whether you're the administrator and whether you can do something. And the early versions of it, you could just inject extra XML tags and give yourself more permissions on the way in and out. So that's the game. So the app gets the login. So now, instead of just passing it on, it checks to make sure that it's not attack data and it's only a certain length. Then it has a SQL query. The SQL query escapes a bunch of dangerous characters before it goes out. Then the login succeeds, and it blocks the XML meta characters to make sure that nobody is sticking XML code in their name and password, which would change it. And then it displays the information back. So this stuff is HTML encoded so that you can't have cross-site scripting. And these are not perfectly secure, but this is the kind of thinking. Every step, every time data goes from here to here, somebody from the security team has to come up and say, all right, what are the things that could go wrong here? And we better put in all these blocks to block this and this and this. So, and Filters tend to be really bad. So if you put in a filter that uses, say, regular expressions to take out the script, then all you have to do is send up this, SCR, script in the middle, it'll take out the script in the middle and turn it into script. Now you might say that you have to iterate everything a lot of times. If you actually make a loop and iterate until it's done, then you create a DOS attack. I can just make a string that will cause it to run around in circles forever. Then here's another fun one. So first you take out this. You're trying to stop people from doing directory traversal and going up above the directory they're in.
Yeah.
So you take out .. then you take out .. So all you have to send is this. It will not find the .. because there isn't any. It will then take out the .. and now you've got .. This is like a fun little crossword puzzle kind of game that hackers play. You'll do it in CTFs and everything. All these filters are just a cute little puzzle. Oh, somebody put in a filter. Oh, this will be fun. Then this is the one that Microsoft did. I think it was IIS version 4 had this problem. When you put things in a URL, like up here, I've got a URL, and if I put a space in this, and press enter, the space turns into %20. It changed pretty fast there because my server was rude. Let's go to a CCS server that isn't as friendly as mine. There. So ccsf.edu, if I do ccsf space, it'll change. Yeah, I'm not seeing it very well. Anyway, the point is it'll put a space in the URL, it turns it into %20. Your browser will do it automatically. So then you have to decode it before using it. Everything that passes through the URL is URL encoded. But Microsoft made an error and decoded it twice in one of their IIS versions. So if you wanted to pass an apostrophe up, that's %27 and a percentage %25, all you had to send was this, %2527. It will be decoded, the %25 will turn into %, it'll be decoded again, this will turn into an apostrophe. So your SQL injection filters that are blocking apostrophes, by blocking these, will not work. You can send in something which after the decoding turns into the forbidden character. And this is how you sneak past all these filters, even the smarter filters. So then you've got to handle attackers. There's a bunch of things. When people are attacking your website, they generally gain valuable information, and you would like to prevent that from happening if possible. So errors, for example, if you don't handle the errors in your program, where you do something like try and accept in Python, if you don't handle it, then it will default to the operating system creating an error or the web server creating an error, and it almost always dumps out, but here's the code that failed, this is what you don't want to tell the attacker. This is like handing them exactly what they need to know. I remember a few years ago, like I say, before I found out it was illegal, I went to the DNC, Democratic National Convention website, then I went to the Republican website. I put a couple funny characters in the URL, and the whole page turned into like screaming red ASP source code, and I said, oh, I think I better stop. But it was really fragile. The Chinese little weird thing, and we just dump out all the source code. It's better now. But anyway, you're not supposed to do that, I should mention. You're not supposed to check for security problems on someone else's site. I thought it was okay, but it's illegal. The Computer Fraud and Abuse Act says if you send a signal to somebody else's server and you gain information you're not authorized to have, you've now broken the law. You don't have to do any harm, you don't have to run any code, you don't have to have any malicious intent. It's very, very annoying.
They'll break you off like 5 years nowadays, man.
Well, if you do it in like a harmless context and you cooperate with your attorney, you might get by. There's a gray zone, but still it's technically illegal, which I didn't know. I was off complaining to people and demanding better treatment and everything, saying I didn't hack anybody, and then my lawyer said, well, technically you did hack them. I said, dude, I did a Google search and I found their stuff. He said, well, that's hacking them. I said, wait a minute now. How is that hacking? He said, well, it is. Now, if you'd gone to the Google cache, then it wouldn't be you that hacked them, but Google that hacked them. But since I actually went to their site and looked at their stuff, I hacked them. I'm like, dude. Basic rule is anything fun is forbidden. This is the way like Calvin and Hobbes feels in Calvin and Hobbes. You know, he asked his dad for a rocket launcher. Why is life no fun? You know. So anyway, so audit logs. You should be auditing things. This turned out to be pretty hard to make logs that will actually let you see attacks. You certainly want to log in things like authentication, success and failure, password changes, things that are blocked. You want to log them because those are probably attacks, people trying to get in with the door that's shut. But for high security, log every request in full. And I learned this, the project you'll have, the SQL injection project, I put it up on the web, let people attack it, and they did things I didn't think they could do. And this guy said, how did you do that? He like defaced my page and put up images where I thought he could only put in text. He said, well, I'm not going to tell you, you figure it out. And I had to go through like 3 stages of increasing my logging until I discovered Apache forensic logging, and it does this. Every single complete URL is saved. That turned out. And now I can finally see what he's doing to me.
Do you like with the logs, do you use like a Perl script or something to like kind of Because you know how you can get so many logs, so you want to search for a
Yeah,
certain type
I
of
haven't done
attack, so you
it. There are a
like-
bunch of SIM products to do this,
Yeah.
like Alien Vault, where you put a agent on the machine and it exports the log, and then it puts it in a giant engine like Google, so you can search it with CAN
Right.
queries. And that's the boss solution. You put agents everywhere in your network, you aggregate them in one place, and then you have join a community like the Alien Vault community that gives you filters to search and find. This is
Right.
a DDoS, this is SQL injection. That's the boss way to do it. And I know some banks that have worked. I had students in my hacking class that, unbeknownst to me, decided to do their homework at work. So he's at work, like at a bank. He's downloading like Kane, a hacking tool, and before he can even run it, the phone rings. Knock it off. What are you doing down there? And that's what your logging should be. This thing just calls the administrator. Some idiot is downloading Kane. Fire this guy. That's what it should be. I mean, anyway. So your logs have to have times, IP addresses, and usernames, and they probably also have cookies. Mine certainly do now. So now the log is now a high-value target. If people can steal your logs, they can totally steal credentials from users and get in. One fun thing I saw from Troy Hunt was ELMA servers. There's this thing called ELMA, E-L-M-A-H. It is a common log management server used on Microsoft-oriented networks, and there are hundreds of them that are just open exposed to the web. And what you do is you just go to their website and put like a bad character in the URL. That creates an error, and the error will show up on the ELMA log. And every log entry has the cookies and everything. So what he did was he put a link in Twitter that would go to the website and have a bad character. Anybody that clicks the link, if they're logged in, their cookie goes in the error log and you can just steal it. It's bloody awesome. And that's another one. HTTPS will do nothing. It's not an issue of stealing network traffic off the wire. It's an issue of the cookie getting to the server and the server putting it somewhere stupid where it serves it out to the world. And this is with the best of intentions. They're trying to log things properly, and they're trying to make it easy for their administrator to check the logs, and suddenly they created a worse problem than they had. So you got to put your logs someplace safe. One good thing is to put them on a system. See, hackers are going to try to erase the logs, and they're going to try to read the logs. So one thing you want to do is put them on a separate server where the only thing it can do is add an entry to the log. There is no command to delete the entries or to read them. And you might even write them to write one's media, so they can't be
There's no way
erased.
They can communicate out.
Right. That's the plan. That's why I know if you want to log network traffic, the way to do it is to connect at layer 2 with a machine that has a MAC address but no IP address. So it cannot be addressed. It can copy the traffic, but there's no way for it to phone home, there's no way for it to receive commands, and there's no way to detect it with any kind of scan, so you don't even know they're doing it. The problem is, when I log network traffic, it's almost all useless because it's almost all encrypted. So real logs that log things like URLs are much more valuable than network logs, unless you go to the bother of having the keys for everything, which you can do, but it's getting pretty annoying by then, and I got that stuff going. Anyway, so you watch for, now some things you can detect attacks in process and you want to tell the administrator, like a lot of requests from the same user, a lot of funds transfers to or from the same account, these sort of things. These are things where you probably should alert the administrator. Something really bad is happening. Perhaps you should consider taking the whole thing down for service, like all the stupid Bitcoin exchanges that got hacked. And some people stole all the money. You know, why didn't they? All the money is vanishing. Maybe we should shut for today. You know, that would be nice to notice this before all the money vanishes. Anyway, you got firewalls. The problem with firewalls, of course, is there's a separate box just stuck on the wire, and it doesn't have any clue what app is protecting in any detail, so it can only stop the most generic attacks. So it can stop generic SQL injections, but it's not going to detect more subtle problems caused by your business logic. And once you react to attacks, attackers are going to probe, so you can do things just to irritate the attackers. And there was a fun talk going through the security conferences about 2 years ago of a guy that had about a dozen ways to hurt the attacker. One of them, I argued about whether it's legal. He put a file on there with a name like payroll that contains a horrible virus and let them steal that file. Sure, good fun, good luck with that. But you can put things up that will irritate them. This really old one is a tar pit. That's the one they're talking about
That's
here.
probably illegal though. If you put up a
Well,
virus.
you know, in a way, we
are.
argued about it. I know in New York City in the 60s, there was a guy in like Harlem who kept getting robbed, like a liquor store. So he got so fed up, he wired up a shotgun with some wire to the back door. So when he opened the door, they would get shot. And somebody got shot, and they declared that was not legal. You can't be doing that. But if you put a virus on your machine, in a folder where no one's supposed to go, and someone steals it and then it gets hurt, I don't know. It's going to depend on your lawyer. Yeah.
The same was pretty recent. Some researcher get the text count
Yeah.
phone call, he let them log in, but he made available only the executable for Loki. So the person
Yeah.
who was actually trying to take over his box got busted with Loki.
Yeah.
And that's a big question about like, is it ethical or legal?
And then there's the FBI that caught all the pedophiles by tricking them to install malware, and they're still arguing. Like, exactly what judge do you go to get a search warrant to give you the right to install malware, and what about the people that are not within the jurisdiction of that judge? They're still in court. That's the kind of thing that'll walk around for a while. It's a problem. This is why you need to have a lawyer, and you need to accept that you're taking some risks with everything you do. And that's why you have lawyers, so you can wander a little bit in the gray, and hopefully they can save you before you drown. You don't do abundantly stupid things, but doing anything you have to do just to get through the day involves some legal risk in this business, because the laws are so very far from what they need to be.
Yeah.
And it's not just that there's this gigantic problem between the social people and technical people, it's also that it is very hard to define exactly what a cybercrime is. Like, we'd like to say, if someone comes in your machine and runs a bunch of code without even telling you and changes your machine, that's a crime, except there's something called Windows Update that does exactly that. And so in what way is me putting a rootkit on your machine and taking it over and stealing your password different than what Microsoft does every day? What exactly is that? How do you write a law that will really make a difference between those two that we can clearly understand? It's not
Like, I
that
can write a
simple.
law like, I don't like that.
That's right,
It's like,
exactly.
I don't like that.
And then you got whole industries like the PUPs, potentially unwanted programs. They make these things to make pop-ups on your screen, change your browser page, change your search page, and they claim to be legal. And they sue any antivirus company that cleans them off and say, there was this terms of service, and down page 10, you said, I agree to have ads pop up on the screen. So they agreed, they wanted this stuff, it's legal. And that might even be true. It's a problem. Anyway, so but this is a tar pit where you just respond really slowly to requests so you can't get anything done. That's a pretty cute one. Anyway, then there's a management interface someplace, right? For your management. By the way, PHP Nuke is what the U.S. military uses, the Department of Defense. Holy crap! I mean, I was in the DoD pen test they had about 2 months ago. Now they're going to have another one. I got in. You could get in pretty easily. I didn't find anything great, but what I did find was they're running everything on PHP Nuke, I think, or no, WinNuke. Anyway, there's these. So there's an administration interface someplace, like your WordPress management interface, where you can log in and do things. So now, this is of course helpful for the administrator to do things, but it's now a high-value target. Although, as far as I can tell, nobody's trying. I put up a WordPress blog with a password of PASSWORD, and it sat there for month after month. The only thing I got was comment spam. There are no bots trying obvious passwords. Anyway, so you can hack the administration panel. It often is poorly designed, so you can do things like a router administration panel without really having logged in, and on it goes. So that's the couple chapters in the book I wanted to talk about. And let me just point out the projects. I got a few of them here. What these are, the first few projects here are the ones I've been doing at DEF CON and all the conferences, because this stuff turned out to be a lot of fun. So you should be able to do this stuff. It's pretty easy. So the first thing, if you don't know anything about Bash, I made a really simple Bash project. So you got to learn how to do a little Bash. If you do this stuff, you don't even need a virtual machine or anything. You can just go to an online Bash shell. But the point is, you should know a little bit of Bash. Is there anybody that's never used Bash? Well, then forget this. All right, good. So, all right. So anyway, I made a task where you have to use a little bit of Bash to learn how to do something. So you learn how to put your name in a file. So now, let's exploit the ping form. This is a form which I understand most routers have this vulnerability, according to what another guy said at B-Sides. If you go to the router page where you check your internet connection, you can put in a URL and it will ping it, like google.com, and it will now ping it. Now, this is all three of these projects are OWASP 1, the number one most dangerous vulnerability in the world, which is command injection. This is the easiest one to exploit and the most deadly. And these are the simplest kinds of command injection. So now it pings Google, but the way it does it is it takes whatever I put in, writes the word ping, followed by whatever I put in, and executes it in the Bash command shell. This is an easy way to write programs, is to use one language to make a command and then execute it in another language. It's also extremely dangerous because I could put in something that's misunderstood. So that pings, but I could just put a semicolon here and do an ls, and it will ping and then do the ls. So this is command injection. I can do something the developer did not want me to do because they didn't think about me putting in unusual input here. And so now you got a challenge. Put your name in this file and then you'll end up on the page of winners. and that's pretty easy. And when you get on the page of winners, take a screenshot of it and turn it in. No test here. A whole lot of people did this though. Almost everybody was able to do this one, and they get harder as you go forward. So try that one. That should be pretty easy. Then after you're done with that one, task C, the next couple tasks I put down here in extra credit. So if you want to play with a few more command injections, the next one is a buffer overflow. Now this is kind of fun. This is not the most common type of buffer overflow, but it's a very dangerous one that's very hard to prevent. So here's the code that I wrote. Down here, it takes, it prints out a couple of addresses just so you can see them. Then, here it takes in your name. You put in your name, and then it defines a variable that contains uname minus a. Uname minus a is just a simple Linux command that tells you what version of Linux you're running. But the point is, it's going to now execute that command, system C. But before it does it, it's going to copy it into buffers that are smaller. So the result is I can take a name that's up to 200 characters long, but down here it's going to copy it into a box that's only 40 characters long without boundary checking. So when you run this, what happens is it stores the name at one address and the command down here. So if your name is more than 40 characters, it leaks into the command. And this is the kind of thing that is very hard to stop because it doesn't really hit a canary. It doesn't cause a stack smashing exception or anything. Most of the buffer overflow defenses cannot detect this kind of overflow. In fact, I'm not aware of any defense. The only defense I'm aware of is very weak. Microsoft's Visual Studio now has an algorithm to place the variables on the stack in a certain order to try to prevent this. But it's very weak. Anyway, so if you put in, here's the form, if you put in your name and say execute, it says name, Sam, and then it executes this command. But if you put in this name, 40 characters followed by ls, it now does an ls because the name variable leaked in the other variable. So you can leak up to 40 characters of bash command line. The problem is you can't do an ls minus l. If you try to do an ls minus l, you'll get an ls because the space terminates this string from the viewpoint of the input to PHP. So you have to figure out how to get a space that is not a space. And there's one way to do it here, although as I went through the security cons, the students had a wide variety of creative ways to make spaces that were not spaces. Here's one that works, there are several others. So that's the first challenge, just do a long list. That's not worth any points here. The one that's worth points is getting on the winners page. So put your name in this file. And there is a cron job running at the start of every minute. It puts them on the winners, and you'll end up on the winners page here when you figure out how to put your name in that file. And that's worth points. And another one is Image Magic, which I just want to show you because it's a lot of good clean fun. This is a real vulnerability that affected all Linux servers in April of this year. It took about a month before they patched it. This is because Image Magic is a library to just manipulate images on Linux systems. It's very, very common. It's in Ubuntu and Kali by default. So if you have an image, like this picture of a flag, you can upload that file. So if I go to my desktop, this is something you'll see, anything that handles images, like your profile pic for your social media and everything else. If I put up the file and upload it, then I just found some code that somebody else wrote for like a forum upload, and all I did was put in pointing out what the commands are. So it removes the old one that's there, removes the thumbnail that's there, and this is the command that creates the thumbnail. Convert it to a thumbnail, 300 by 300, and this convert command is what has the error. So this is what works when you read an image, it makes a thumbnail. When you click the image, you see the whole image. So that's what it's supposed to do. But if you put this stuff in a plain text file and give it an image name, let's save that as on the desktop as attack.jpg. It's not a JPEG, it's just a few lines of text. But the point is the Image Magic library has the ability to modify images. You can fill a portion of the image with a color, and you can get the color from a URL. And if you get the color from about 6 methods, one of them being HTTPS, it fetches it by building a bash command line that says curl followed by whatever you put here, making exactly the same mistake as that ping form. So you can put in echo hello over here and it will run. You can put a semicolon date and that's the game. You can put commands in here which will then ultimately run as bash command lines. So this is going to echo hello and then print out the date. So when I put up that thing called attack.jpg and upload it, it prints hello and the date. So I can now insert bash command lines into my image file and run them. And so
And when you say bash command lines, you could use curl or the wget. Or
it's
you could
dash.
download.
I should say it's dash and not bash, which is a big issue. There's a thing called shell shock that affects bash. And everyone's freaked out, and it turns out almost nothing exposes bash. Bash is for humans to use, and it has a history and all kinds of expensive things. If you are in a script or a program and you make a command line, it executes in the default shell, which is dash,
Okay.
which is not bash. It doesn't have as many features, but it's pretty much the same. You have most of the same commands, and you can totally. So you can put yourself on a winner's page. You can make a careful exploit here that will put you in this file, and every minute that file is scraped and put into the winner's page, so it'll end up here. Anyway, so that's the extra credit there, and there's a bunch of others here. The SQL injection is a big one. I think I'll go through it next time. Some of my students have already done it, but this is really fun. You should totally learn SQL injection, and then there's some challenges too. This is the particular one that is most exploited on the world, the particular form of command injection that is responsible for almost all stolen data. And then down here, you start using burp, and down here you start using the Z-attack proxy. I'll just mention the Z-attack proxy one is good, clean fun because of this site that somebody wrote, Hackathon. Hackathon.slams class. This is something, a training tool somebody put up, and it is wonderful. Hackathon is an imitation Amazon, all full of security flaws. So you will,
That's so cool.
and you can make an account, and you can sign in, and you can shop for things. And it has every possible problem, of course. I put it up on the cloud so we can all play with it. And I got a backup so when you kill it, I can restore it. And anyway, we'll be using Hackathon a lot because your textbook author actually runs like a pay service to let you practice attacks. And I can't make students pay for that. So I'll duplicate it with other things. But I think most of it's going to be in Hackathon. Anyway, so anyway, this is something somebody wrote. So anyway, the point is, the first thing you do is download the Z-attack proxy and just run a vuln scanner on this, and it finds lots of fun vulns. So anyway, those are the first few projects. None of this stuff is due for a long time. I don't make things due until after the ad period's over. But anyway, the first quiz is over here on 9/19, and then projects start being due. So you should start doing them. So do these are ones I recommend, and here's extra credit projects. And there's always a lot of them. So if you do a lot of these, then you can make up for missing quizzes and not even take the final and all that. Yeah.
For the command injection, I'm
Yeah.
just kind of confused by